Our next lesson is a continuation of transformations of graphs of functions. And our first type of transformation is the reflection. So the first one you see is if you do something to your parent function and you make it negative, you are going to get a reflection over the x-axis. And if you do something, take the x and then make it negative, you are going to get a reflection over the y-axis. And I'll give some examples so you can see what it looks like. For our first example, we will be graphing h of x equals negative square root of x. So this graph is actually going to have a parent function. Hopefully you recognize that our parent function is going to be square root of x. F of x equals the square root of x. And so for the negative square root of x, we're actually going to be reflecting it over the x-axis. So first I'm going to draw my parent function. If you remember from the last video, y equals the square root of x is kind of like this. So then my parent function, or my transform function, is the negative square root of x. And if you want, you can make an xy table and look at every single point. But you will find that if you do that, every single point will have the same x values. You still can't have a negative x, but every single point will now, y value will now be negative. So this is going to be reflected over the x-axis. So it's going to look like this. And this is my h of x. Now, for my next one, number 2, that one also has the same parent function of f of x equals square root of x. So I'm going to draw that first. However, for this one, we are going to be reflecting it over the y-axis. And once again, if you want, you can draw an xy table. That always is an option if you get stuck on how to do this. You'll find that the only values that you can put in without getting a negative under the square root are negative x values. So what's going to happen is this one is going to be only the negative x values. That's actually going to be our domain. So this is my g of x. So then every time you see something where you only are making the x negative, that is going to be a shift or a reflection over the y-axis, whereas something where you make the whole entire function, the whole entire parent function negative, it's going to be a reflection over the x-axis. So for the next 2 problems, we're going to actually put several things together. So we're going to put together reflection and vertical and horizontal shift. So for number 3, the first thing I want you to notice is that our parent function is f of x equals x squared, which, if you want to draw it, it looks like this. So now what we're going to do is we are going to figure out how to get from the parent function to the new function. So there's 2 things going on. First thing that you do is look at the reflection. So what we did was we took the x squared and we made the entire x squared negative. We made the parent function negative. So that is going to be a reflection over the x-axis. Just a side note here, for this one, actually, if you try to reflect it over the y-axis, you won't get anything special. You'll get the same thing that you started with because this is an even function, which means that it's symmetric around the y-axis. So we're going to here have a reflection over the x-axis. So what we're going to do is we're going to first reflect it. Once we've reflected it, then we are going to move it up 4. So that's a vertical shift of 4. So what's going to happen is my new vertex is actually going to be at 4. But now my graph is going to be the exact same thing that I have, the exact same shape of parabola, but it's going to be upside down. So this is my new function. So there's several things going on here. And actually the next problem, we have even more going on. So for number 4, your parent function is going to be f of x equals absolute value of x. If you want, you can draw that. By the way, you don't need to draw these parent functions every time. I'm just drawing them so that you can see what's happening. So there's actually 3 things going on here. First thing is that we are going to have a reflection over the x-axis. We know that it's going to be the x-axis because it's outside of the absolute value bars. The second thing is there is a horizontal shift which is going to go to the left 2 spaces. The last thing is that we're going to also shift down 1 space. There's a vertical shift also. So this is the stuff that we did in the last section. So it's just a little bit more complicated. So there's 3 things that are going to happen. First thing we do is we flip it over the x-axis. Then we move to the left 2, and then we move down 1. You'll find that in the end, when you go down 1 and you go to the left 2, your new vertex is going to be right here. And you have the same shape. You're just going to be facing the other direction. So this is my new function, g of x. So our next topic is the vertical stretch and the vertical shrink. So there's also horizontal shrink and stretch. We're not really going to go into that in a lot of detail. The main thing I want you to note is that when you have a coefficient in front of your parent function, if the absolute value of your coefficient is bigger than 1, you're going to have a vertical stretch. And what I mean by that is your graph gets more narrow. And if you have a fraction or a decimal that's between 0 and 1, for example, 1/2, 1/3, you're going to get a vertical shrink, which means that your graph gets a bit wider. So let's do some examples. So for these next 2, the first one is going to be a vertical stretch, which means it will be more narrow than the parent function, which, by the way, is x squared. The second one is going to be a vertical shrink, which means that it's going to be wider than the parent function, which is also x squared. So before I do anything else is that I need to draw my parent function so we can compare them. So my parent function is going to be the graph of y equals x squared. And before we go through the new graph, the few things I want to point out is that a few of these points on here, we have 1, 1 on this graph. We also, actually it doesn't look like it, but 2, 4 is on the graph. I didn't draw that too well, but that's what it is. We also have -1, 1 on the graph, and we also have -2, 4. Once again, didn't draw it perfectly. So what you're going to do is you are going to, for your new graph, actually each of these, for every x value that you put on there, the y value that corresponds to it is going to be doubled. So we're still going to start at 0, 0. So our point at x equals 1 on the original graph was 1, 1. Now the point is going to become 1, 2. On the original graph, we had a point at 2, 4. That point actually on the corresponding graph is going to be 2, 8, which is all the way up here. So on the right-hand side, it actually is going to look like this. Left-hand side, it's going to be the same. So it's going to look like that. And you will find that your graph that you have here in blue, which is my g of x, is going to be more narrow. So this is what we call a vertical stretch. It's like you're taking the entire graph and you're pulling it from the top. So that's why we call it a vertical stretch. The next one's a vertical shrink. It has the same parent function. And that is still a parabola. It still has the same point on it. So this is my f of x. So now what's going to happen is every point I have on the line actually is, for each x value on my new line, the y value that corresponds to it is going to be half of the original. So, for example, here I had the point on the original, the parent function, I had the point 2, 4. On the new graph, that point's actually going to correspond to 2, 2. On the original, you won't be able to see this on here. I had the point 3, 9, but actually on the new one, it's going to be 3 and 4.5. So what's going to happen is my new graph is going to be kind of similar, but it's just now going to be a little bit wider. So this one in blue is my g of x. By the way, in case you're not sure about that 2, 4, that was on the original graph, not on the new graph. So if you want to keep that in mind. And then the corresponding point on the new graph was 2, 2. You do not need to write the points, by the way, but I just kind of want you to see what's going on these. So the key thing I need you to know is that a vertical shrink, which means you have a coefficient between 0 and 1, is going to become wider, and a vertical stretch, which means you have a coefficient whose absolute value is bigger than 1, is going to become more narrow.